Hello.
Welcome. Would you like to introduce yourself?
Sure. Hi, everyone. I'm Janisha. I'm the product manager for SageMaker Autopilot. And for those who don't know what SageMaker Autopilot is one of our low-code machine learning services within AWS, which helps you build, train, and tune machine learning models while maintaining full visibility and controls into building them.
Okay, so what we just saw previously was SageMaker kind of the model gets deployed to the end user. But we've talked to SageMaker folks quite a number of times and understand there's a whole suite of products. So the phase that you're dealing with is primarily, if I understand correctly, the training phase. So I have some fresh data, and I want to train a model now, but it's not even ready to deploy yet. I'm just starting with the raw data, and now I want to actually train
Right.
model on the data.
Exactly. So what
Okay.
Autopilot does is it actually takes away the heavy lifting of building a machine learning model. So what you essentially have to do is you have to provide it a tabular data and just select the target column that you want to predict, and it will take care of the entire heavy lifting for you. So essentially, automatic data pre-processing, automatic feature engineering. It'll select the algorithms for you. It'll run select the number of hyperparameters, or if it is an ensemble mode, which is what I'll talk about today in detail. It will essentially build those configurations for you and build multiple runs within the Autopilot experiment. So what we're doing is we're not just giving out or just running a single model. We're building multiple models for you behind the hood, and then we give out the output of the final model to the customers, for the for the objective matrices that they're training the model for, and essentially give them a view into what are all the trials and the runs that we ran for them behind the hood. So essentially, it's not a single training job, but it's called an autopilot experiment because it runs multiple trials or runs for you with different configurations and takes away that part of the iterative process from the data scientists who would have to do this repeatedly, one after the other with different configuration parameters.
Yeah, that's so useful. I mean, like, honestly, the most frustrating part of machine learning is always like picking the right model and like setting your hyperparameters, and like you just spend weeks just kind of screwing around trying to find the right thing. It's like I would totally use this.
That's what customers are loving about the product. Yes.
Yeah, I remember the first time I tried to train a machine learning model. I spent so long just trial and error, messing around with different options, and it would just produce junk data. So I was like, I don't know what I'm doing.
Like how machine learning doesn't work.
Hopefully the demo will change your perception and showcase how easy it is.
Okay, so what is different about SageMaker Autopilot now? What is it solving to make that easier?
Sure. So all this while, so we've been out since 2019. It's not the first time we're launching Autopilot here. But what we had was we were always training our models using HPO, which is hyperparameter optimization technique. It's a technique of machine learning where you briefly touched base upon that, where essentially you first have to prepare your data with feature engineering transforms, and then you essentially select your algorithm that you want to pass, apply to your data, and then find a range of hyperparameters. So Autopilot was essentially doing that. It was doing the automatic data preprocessing, feature engineering, selection of algorithms. HPO mode within Autopilot leverages three algorithms: XGBoost, MLP, and linear learner. And then it selects a range of hyperparameters for you. And that's what I said, number of trials based on the kind of hyperparameters it has chosen. But as the data, different data has different characteristics. And different characteristics means they have not a single algorithm can apply to that sort of a data set. So essentially with hyperparameter, a single trial that would run would essentially have used this combination and would just use one algorithm. So we were getting this feedback from customers that they want to use a diverse set of algorithms. We also got a feedback from customers that HPO, because it creates multiple trials to get to that most optimal model, performant model. It takes a longer time, exceptionally long time for training. So we heard those two, feedbacks from the customers that were coming back, and we launched a new training mode within Autopilot, which is called the Ensemble training mode. So what's different about Ensemble training mode is that it no longer just takes a single algorithm. An ensemble is essentially a machine learning technique wherein you combine various outputs of various base learner models, which is multiple algorithms, and then you combine that and you average out the output to produce one final optimal model. And Autopilot leverages AutoGluon under the hood, which is a very popular open source framework that is out there for ensembling, and it leverages Ensemble with stacking. So essentially, it uses all the algorithms that AutoGluon Tabular offers, and then creates that final output model for you. And in terms of speed, the Ensemble models are around in Autopilot are 8 times faster than the HPO training mode models with 250 trials. For datasets that are less than 1 MB, and for datasets that are less than 10 MB, it's essentially around 6x faster. So we've kind of solved with this launch, we've solved for multiple problems. We've solved for the slower training time. So we're giving faster training time to customers. We've solved for the diversity of algorithms. That was only 3 in HPO, but with the Ensemble mode, we have 8 of them. We cover XGBoost, random forest, extra trees, light GBM, cat boost, a couple of neural network algorithms for fast AI and PyTorch. So the diversity of the algorithms problem has also been solved with this particular launch. And the biggest one is that now customers have a new technique. They're not just tied into using the hyperparameter optimization machine learning technique. They can essentially use the Ensemble training technique to get models without compromising on the model accuracy.
So if I understand correctly, it sounds like the optimization here is that rather than going like super deep on one model and trying to find the most perfect parameters, we can instead go wide.
Exactly.
We can use multiple training models at once and then combine their efforts together to get potentially more accurate result too, right?
It does. So we've seen from all our benchmarks that we've done, we've never seen an Ensemble model perform worse than HPO. Indeed, we've seen around 1 to 2% better model accuracy than what it was performing with HPO. And Ensemble as a technique itself is known to produce very stable models. And so, yeah, we've adopted that part as a part of the new launch.
So this just sounds like wins all around. I don't have to be as experienced, so I can just let it kind of look through the different models and find what works. It's faster and it's more accurate. Like wins all around.
Right.
So I understand you have a demo. You're gonna show us this in action, right?
Absolutely, sure. Can you see my screen now?
I'm bringing it up now. There you go.
Sounds good. So what I am currently in SageMaker Studio. So Autopilot, if you want to access it through the UI, it is available in SageMaker Studio. And you always, obviously, like all of our AWS services, you can use the SDK of Autopilot to launch an Autopilot experiment as well. So I already have a user pre-created in SageMaker Studio here. And I'm just bringing up the launching pad and the launching screen for SageMaker Studio. And here, right in the middle, there is a card which says build the models automatically, and you can essentially create an Autopilot experiment. But before I go ahead creating the experiment, I just want to talk about the use case that we are going to be solving for here and what kind of an Autopilot experiment we are planning on building. So I already have an auto insurance claims data set with me. This is around a 5 gigs database with around 21 columns, which kind of combines the customer details as well as claim details here. And what I want to do is I want to understand, it's a binary classification problem that I want to solve for, wherein I want to understand whether this claim was fraudulent or not. That's essentially the problem that I'm trying to solve for with Autopilot experiment. And so I'm going to trigger an Autopilot experiment here. I'm going to walk you through as to what are the steps that we need to take while creating an Autopilot experiment. I want to emphasize that Autopilot gives you the ability to automatically do everything. Essentially, the only 2 minimum parameters that you need to provide it is the input data and the target. And at the same time, it lets you customize your AutoML journey as well. So if you're a data scientist who wants to say, put your own data, bring your own data split, or select your own features, or select your own transforms, or select your own training mode, you can absolutely do that within Autopilot. So it gives you that plug and play ability for your experiment as well. So I'm just going to assign a name for my experiment, and then I'm going to select my input data. So it lets you preview this data right here. You can see that this is the right file for me. And Autopilot automatically does the data split for you at 80-20. So training data set as 80 and validation data set as 20. If you were not to do that, then you can specify your own custom split ratio, or you can upload your validation data set, provide your own validation data set out here. So I'm just going to let the auto split work. You can also create an output location or let the output location be created automatically for you. So we're going to let it create it automatically for us. In the next screen, you have to specify your target. That's the most important column that you need to provide. And here my column is called Y, whether it is a fraudulent claim or not. And then you also have the ability in Autopilot, and this has actually been a very new launch, though we're not going to talk about it in detail in this particular session here. But essentially, Autopilot does give you the ability to select and deselect certain features. So for example, this particular data set has 21 features. If I feel that the job and the marital status of the customer is not going to have any impact on my model, then I may remove it. It's just an extraneous feature for me. You also have the ability of changing the auto-infer data type. So if suppose you want to explicitly change a text data into numeric or a numeric to text or categorical, you can absolutely do that and change the auto-infer data type. So for simplicity's sake, we're just going to leave in all the features that are out there and see what Autopilot determines is the most critical feature. And so we're going to give it the entire data set with all the features in it. The next part is that you have the ability of selecting the training modes. By default, the auto mode is selected, wherein you are giving Autopilot the ability to choose what kind of a training engine you want to expose your data to and build your models with. And the basic logic here is that if your data set size is 100 MB or less, then we will automatically choose the Ensemble training mode, primarily because of its performance, its speed, and the stability of the models. But if your data set is greater than 100 MB, from our benchmarks, we've seen that HPO actually tends to perform very good with larger data set sizes. So the auto mode will automatically determine, based on your data set size, which training engine or methodology should it expose your data to. For this demo, I'm going to explicitly choose Ensemble because I want to talk about what the Ensemble training mode actually does and what is the differentiator between an Ensemble model versus an HPO-driven model. Then I move to the next screen. And the next screen, you have the option here. I'm at the deployment page as well as the advanced settings page. So Autopilot is not just a service that helps you train and tune your model. It actually, I just want to back up a little here. It essentially is integrated with all of our low-code, no-code ecosystem, as well as the broader SageMaker ecosystem, which means essentially that a data scientist's journey can begin from the data prep side or the experimentation or the experimentation and training side. So Autopilot lets you connect from all these aspects. From if you were bringing in your data from, say, Data Wrangler, and you wanted to bring in your own feature transforms from Data Wrangler, you could essentially plug in, transform your data based on your, the 300 plus pre-configured data transforms that are in SageMaker Data Wrangler, and bring your data into Autopilot and essentially launch an Autopilot experiment from there. You can also enter from where I showed you the entry point, as in you already have a prepared data, maybe in a notebook, maybe with Data Wrangler, maybe with some other tool, and then start your Autopilot experiment. So we went through all the phases of what goes into building an Autopilot experiment. And then the last part is the deployment phase. After your model is built out, after you've seen the results, how do you want to deploy it? So Autopilot gives you the option of auto deploying it, which is right here. Or if you choose not to auto deploy it, you can always review what that experiment ran like and take a look at the leaderboard, see how your models performed, and essentially it will give a stack rank of models to you, so you can deploy the best model with a single click. And I'll show you how to do that as well. So I'm going to just choose the auto deploy option off at this point in time for this experiment. And I'm just going to walk through the advanced settings. And we'll single click deploy the endpoint after we've seen what the model performs and what is the model performance. So here in the advanced settings, you're essentially choosing a problem type. If, again, as I said, Autopilot gives you everything in auto mode as well. If you don't want to do anything with it, we will see your data and we will determine what kind of problem type it is. So we support regression, we support binary class classification, and multi-class classification on tabular data. If you explicitly want to specify it, you can specify it as well. I'm going to leave this as auto because I know Autopilot does a fantastic job in terms of determining the problem type. Then the rest is runtime configurations. If you want to limit your job to run by in a specific time, it will only run those many number of trials that will fit into that time frame. There are some access, encryption, and security advanced settings where you can specify your VPC, your encryption keys, and your subnets that you know to tighten up the hold here. And then obviously assign tags to your job if you want to use it for analysis later, say for example a cost explorer analysis. With that, we'll go ahead and click on review and create. And now here we can review what the settings are when we're creating an experiment. And then we can click and create an experiment here. I'm not going to wait for this entire experiment to finish. I actually have an experiment that is already launched and has completed. So I'm just going to go into that. So here on the left panel in Studio, I'm going to go into experiments and trials, and I'm going to show you the output of my Ensemble experiment that I ran. So this is what the output would look like once your experiment finished. Now, if you see out here, Autopilot has automatically, and this was an Ensemble experiment, so it ran 10 trials. For datasets less than 100 MB, we run 10 trials. For datasets that are greater than 100 MB, we only run 5 trials. And I'll explain you the concept of what trials really is. But essentially, you have a leaderboard out here showcasing a list of models, and then we've stacked ran them based on their performance metrics. So it trained for the F1 score out here. That was what we were training this model for. And it's given me the best model with an F1 score of 0.673. And I do have the ability to view the details. And if I select this model, I have the ability of, as I said, a single click deploy, and it'll take me to the deployment screen. And I can essentially deploy this model to an endpoint and then invoke it for real-time inferencing.
So for these different model names here, is each of these one of the algorithms you mentioned earlier, like cat boost, XGBoost, or is each of these a subset of those available?
Good question. I'm glad you asked, because I was just getting into the detail of how this is different from HPO, and I'll actually explain you what HPO also does and why Ensemble is so powerful.
Okay.
So Ensemble mode within Autopilot, you has 8 algorithms, and every trial is a combination of a subset of algorithms and a different configuration of the AutoGluon configuration parameters. Let me just open the model details and show you what I mean by that. So if you look at this model actually did not just use one algorithm. It used 1, 2, 3, 4, 5, 6, 7, 8. It used all the 8 algorithms, and it created a weighted ensemble of that of this trial. Internally, it ran more sub-trials, one on the base learner model. So it must have run single sub-trials on each of these, and then it created a weighted ensemble here with a numbag value of 1 and with auto stacking as on with true, and it created and gave you the output. And based on this model, it essentially gives you the sharp values of the features, and it tells you which of the features were the most important that contributed to the prediction of the F1 score the most. So here we see that the duration and the employment variation rate are the 2 columns that were the most impactful, had the maximum control or the maximum weightage on the determining the performance of the model and giving you that F1 score. Let me just go into another and I'll get back into the screen to understand the details, but let me just show you the difference between one Ensemble trial to the other. Let's just open up the third or the fourth trial here. Now, if you look at this trial, this is different from the first trial because this one only has 5 algorithms. And I'll talk about a little bit of the algorithms, right? It's not just the same type of algorithms. Now, AutoGluon has a few boosting algorithms, a few bagging algorithms, a few neural network algorithms, linear models, and they're all different because they serve and work best on different data sets. Say, for example, if you have extremely imbalanced data sets that you're uploading, then the best models to actually work on that would be a set of bagging algorithms. So we have a couple of bagging algorithms inbuilt in the portfolio, which will work the best. So there's likelihood that the model that actually wins actually has those bagging algorithms in them. So it kind of uses a different combination of these algorithms based on your data to determine what is going to give you the best results. Likewise, if you look at another trial, you will see that this one here in this case uses actually the 7 of those algorithms. So different combination of algorithms, different combination of configuration parameters. And that's essentially what we've solved for, right? We've solved for the iteration. So what would data scientists actually be doing? They would be yes, they've been using Ensemble techniques, but they would have to fine-tune these subsets of algorithms and bring in different parameters, configuration parameters, to find what is going to give them the best objective metric that they are trying to train their model for. And that's the entire heavy lifting, apart from obviously the feature engineering and the data split and all the good stuff like data prep work and the algorithm selection part. We've taken away the heavy lifting of building these trials and iterations. We've taken the iterations away from the customer, and that's the value that we provide with Autopilot. I want to just dive a little more deeper into the model details here. So if you see the model details here, we've got 4 tabs. The first one is the explainability tab, wherein this is actually the most critical tab, wherein customers love to have their experiment finished and see which feature actually was the most critical one and had the most weightage in terms of predicting, offering the impact on the predictions per se. And then down below, you see the parameters that were used for this trial. Then the next tab is the performance tab, which actually lists out all the matrices. So matrices on your validation data set, right? Your recall, precision, accuracy, F1 scores, all the good stuff that you have out there. This is a classification problem. So we do support multiple plots. We showcase the confusion matrix. We showcase the ROC curve. We showcase the precision and recall curve. Essentially everything or most of the plots that data scientists are already used to understanding what's the ratio between my false positives and false negatives, what's my probability ratios. And so these help you visualize that, and it gives you that out of the box. And then the second last one is the artifacts tab, which actually has all the artifacts that Autopilot generates for you, which is available for customers to take. And this is the reason why we say not only do we give you visibility into the trials that we ran within your experiment, we give you full control as well. So you can essentially take your input data. You can take how we shuffle your training and validation splits. You can take the model artifacts. This is the inference container that we've created for you that you can essentially either use SageMaker for deployment or take it away out of the platform and deploy it in another platform. So it's essentially a model zip file that is available to you to take, and not just for the best candidate, but for every single candidate and the model that we generated for you. And then here are all the explainability artifacts. So all the performance artifacts, the explainability artifacts that I shared in these 2 tabs essentially can be downloaded as reports, and you can, or JSON file, in whichever format that you want to consume it, essentially take that for, and run with it and see it. And the last tab is the networking tab. I want to quickly touch base on the difference between the Ensemble. So I had an experiment that I ran with the Ensemble, which I showcased, and I also have an experiment that I ran with the same data set with an HPO trial. So I'm going to just quickly switch gears and describe that HPO job here real quick. Now, if you see the HPO job, and I ran this with the default HPO trials, and if you see there are lots and lots more trials out here in HPO than what we ran in Ensemble. And an HPO...
There's a lot more variability too.
Yes.
The other ones that were all in 0.6. This one had some that were really low down there.
Exactly. Yeah, because so what happens is obviously it starts off from ground up, right? So the first few trials, you'll not get the best performance. And then as you keep going and adding more trials, and that's the reason why we run a default of 100 trials in HPO, and you can always dial it up and dial it down. Earlier we used to support 250 trials. We brought down the default to 100 trials because we made some performance improvements to still give the performance accuracy to customers with the 100 trials and not having to go up to 250. But if customers want to go up to 250 trials or even beyond that, we do support that number. There is no end to it. But essentially, we found out a better mechanism in HPO as well to select the range of hyperparameters and get the optimal range of hyperparameters to customers, and so that they are not doing the heavy lifting of finding out what tuning parameters should I put, what will give me the best accuracy that is out there. So if you look here in this, let me just open up, let me actually open up the best model here. I can either do the view model details from here, or I can just right click and open the model details here. So if you look at this model, towards the end, there will be hyperparameters because this is an HPO training mode autopilot experiment. If you see these are the range of hyperparameters that we used for this particular model, and the kind of algorithm that this model used was essentially an XGBoost. So it's very different from Ensemble because Ensemble is a combination of algorithms, whereas in HPO, while we do support 3 algorithms, multiple trials use just the pipelines that we've generated, the feature engineering pipelines, they used one algorithm out of those three, and then the set of hyperparameters has been chosen for that particular trial. So the mechanism of how the HPO job is built versus an Ensemble job are built are very different in that regard. And if you see that the HPO job actually selected duration and the Uribor 3M column as the two important features that contributed to the feature selection. And if you look at this is the HPO. Let me just go back into the Ensemble training mode. This had an accuracy of the F1 score was 0.673, and if you look at HPO, it actually had a objective metric F1 score of a 0.648. So if you see the Ensemble mode, even if we ran lesser number of trials, because of the combination and averaging out these base model outputs into one final optimal model, we found out not only did we have to run lesser trials, but also did we have to, but also we got better accuracy as compared to the HPO mode that we just showcased. Having said that, we're not saying that HPO gives you less performant models. What we're trying to say is specifically for smaller data sets, less than 100 MB, Ensemble ends up working faster, gives you more accurate models. And for HPO, we're doing a lot of optimizations on HPO as well. We're not discounting that HPO is a very, very powerful ML technique, and we're not taking it away in any manner. But HPO ends up, performing very well for slightly larger data sets, specifically around 100 MB and plus.
That's great. And you know what I really love about this is that you still have the explainability tab in both of them, because that was going to be my question around ensembling. If you're using a lot of different models and you're not sure exactly what it's actually, why it's telling you what it's telling you in the end, you can still actually go in and look at that and be like, oh, it's okay. These are the important features.
Yeah. So we've not taken away the experience in any manner from customers, HPO versus Ensemble. You still get the explainability. You still get your performance tab, which gives you the same plots as we get for Ensemble mode. All of that good stuff is still offered in HPO. It's just that customers now have the option of choosing. They also have the option of not choosing, and that's what the auto mode is all about, right? But they do have an explicit option of choosing their training methodology within Autopilot. And the last thing I wanted to showcase was essentially the deployment phase here. So I just want to go into, if you see, I not explicitly, like I've already, there was this experiment where I had automatically deployed the endpoint. So my endpoints here in SageMaker Studio are mentioned here. I already have an endpoint deployed. So if I describe my endpoint, it's already available to me. So if I go into, it'll tell me which model is my endpoint using. It was an auto-deployed endpoint for me. And then I can invoke this endpoint from my notebook and essentially either run a real-time inference on this by passing it a single payload, or I could run a batch inference on this and do a batch transform job and get my output based on what my requirements are.
Awesome.
Very cool. I really like this. It looks like it not only is making things easier, but also more accurate, faster, ticking all the boxes for folks who want to get serious about training machine learning data.
Yeah. Thanks so much for joining us, Janisha. Much appreciated.
Thank you. Thanks for having me.
Thank you.